Good evening, my dear students. Welcome to IMS Gate Academy. Hi, I am Vipin Mishra and I welcome you all in this PYQ series of IMS Gate Academy. So this is going to be the third lecture in this series, and we have already completed lecture 1 and lecture 2, in which we have discussed the questions of year 23 and 22. Now in this lecture we are going to discuss the questions of year 2021. And we are about to discuss power system and power electronic, which are the two most important subjects for any electrical aspirant. So let's get started with this lecture. So the first question that we have is from power electronic, and what has been asked in this question is, consider the boost converter. So we have been given a boost converter shown in the figure. Switch Q is operated at 25 kilohertz. Okay, so this is the switch which is operating at 25 kilohertz with a duty cycle of 0.6. D is 0.6. Assume the diode and switch to be ideal. Under steady state condition, the average resistance, input resistance seen by the source will be what? So we have been given a boost converter. Okay, if suppose there is no mention about boost converter, we can judge that this circuit is a boost converter, because if suppose this is a buck converter, the inductor should have been at the output side. If it is a boost converter, inductor is always there at the input side. And if it is a buck boost converter, we will be having inductor in between the input and output side. So the given circuit is a boost converter. It is also mentioned in the question as well. Now what has been given to us? We have been given that the operating frequency is 25 kilohertz. So the operating frequency that we have is 25 kilohertz. And the duty cycle is 0.6. So we have been given the duty cycle as well, which is 0.6. Now we have to calculate what will be the input resistance. Okay, so we have to calculate, if we are watching from here, what will be the input resistance. So if we have to calculate the input resistance, that should be equals to, input resistance has to be equals to the source voltage divided by the source current. So what is the value of source voltage? The source voltage is given to us, and this battery voltage is the source voltage, which is 15 volt. But we don't know what is the value of the source current. If suppose this value of source current is known to us, we only have to divide this source voltage with the source current and we will get our answer. So this is what we have to determine. Okay. So we have to find what will be the input resistance here. What will be the input resistance, and for calculation of input resistance we require the value of source voltage and source current. Source voltage is already given. Now we have to calculate what will be the value of source current. So whenever we have to find the value of source current in buck boost or buck boost converter, the one thing that we are going to apply here is that output power is exactly equals to the input power. And the supporting statement we have in the question, that assume ideal diode and switch. So if the switch and diode are ideal, there are no losses in diode and switch. So we can assume that output power is exactly equal to the input power. And whenever we have to find the source current, this is the trick that you have to apply in all questions related to DC to DC converter. So if we apply the power balance, okay, if we apply the power balance, that the input power is exactly equal to the output power, and switches are assumed to be ideal, so this assumption is absolutely correct. Now if we have to calculate the input power, this will be equals to Vs into Is, and output power, it will be equals to V0 into I0. Now we have to find the value of Is, so this will be equals to V0 over Vs into I0. V0 over Vs into I0. So we have to have the value of output voltage as well. So in case of boost converter, the output voltage that we will be getting here, you know that output voltage is equals to what? Input voltage divided by 1 minus D. So let me put this value here. So if I put this value of V0 here, what I will be getting here? If I just put this value here in this expression for V0, what should I will be getting here? So just see, if I put the value of V0 will be Vs over 1 minus D. So I will be getting Vs over 1 minus D into Vs, and I naught can be written at V naught by R. Okay, so just see, Vs and Vs will get cancelled, and again if I put V naught to be the same expression, Vs upon 1 minus D, so what I will be getting? I will be getting a final expression of Vs upon 1 minus D is square into R. So that will be the value of the IS, isn't it? So whenever you have to find the source current, this trick you have to apply. You have to apply the power balance, that input power is equals to output power. Once you will apply this condition, surely you will get the value of source current. And this is the one that we require here to solve this question. So now it's time to put the values. What is the source voltage? So if we put the value of source voltage, which is 15, duty cycle is also given to us. Duty cycle is 0.6. So just put the value 1 minus 0.6 is square. Okay. Now what is the value of resistance? This is also given to us, 10 ohm. So put the value here, 10 ohm. Now when you will solve this, how much answer you are getting? 15 over 1 minus 0.6, which is 0.4 square, into 16. So 0.4 square will be 0.16 into 10. You will get 1.6. So 15 by 1.6, it will be 9.375. So that will be the source current. Okay, so that will be the source current value. Now come back to the statement again. What we have to find here? We have to find what will be the value of input resistance. So input resistance, it is Vs over Is. Now Vs is 15 and you have find that Is value is 9.375. Now once you will put this value, you will get an answer of 1.6 ohm. So this is small exercise you have to do and you will get your answer. I hope this solution is clear to you. Okay, we have to find the input resistance. Input resistance is basically input voltage divided by input current, means source voltage divided by source current. So we are applying this condition of power balance to find the source current. Once the source current is known to us, we will get the final answer, the input resistance. Okay, so this is how you can solve this question. This was carrying 2 marks. Okay, this was carrying 2 marks with it. And if you know the power balance condition for finding the source current, you could have solved this problem and you could have easily scored those 2 marks. Okay, now same kind of question may be repeated in the year 2024 as well. So this is a very important question. I hope this is clear to you all. Now let me move towards the new question. Next question. Again see. So this is the next question that we have. Okay, this question was from boost converter. Now we again have the question from the same chapter. So if you were very good in DC to DC converter, you could have scored these 4 marks very easily. Okay, so just read here what is given in this question and how we can solve this question. Was that a tough one or it was an easy one? Let's find out. So we have in this question, consider the buck boost converter as shown in figure. So switch Q is operated at 25 kilohertz. So you can see, as I was telling you in the last question, if the inductor is present in between both the input and output side, it will be a buck boost converter. You can see here, inductor is right there in middle of the input and output side, and it has been mentioned that it is a buck boost converter. Now it is operating at 25 kilohertz and duty cycle is 0.75. So these two data are given. Assume diode and switch to be ideal. Now this is the line which we are looking for. If suppose this is given, assume ideal diode and switch, then suppose if this line is mentioned in the question, half the problem is solved, because now we can analyze, now we can apply all the assumptions that we have to assume here. Okay. Now under steady state condition, the average current flowing through the inductor will be what? What we have to find here is what will be the current flowing here. Average current across the inductor is what we have to find. Okay. Now many of the students, they have written 0. It's not the average current which is 0. It is the average voltage across the inductor which is 0. Because inductor is taking current, inductor is taking energy in one cycle and it is giving back the same energy. So if it is not consuming anything, okay, so that's why the inductor voltage is 0. Inductor current, when it comes to inductor current, it is periodically varying. So when the inductor current is varying periodically, in one cycle it increases, in other cycle it decreases linearly. So if this is happening, we can say that the inductor voltage, average inductor voltage is 0. It's not the current. Okay. So we have to find the inductor current average value here. Now how we can calculate this? So whether it is buck boost converter or whether it is boost converter, okay, the average inductor current has the same formula. So the average inductor current, that is IL average, this is equals to I naught upon 1 minus D. Okay, and this formula is same for buck boost converter and boost converter. Okay, buck boost converter and boost converter, they both have the same formula for average inductor current. If suppose this would have been a buck converter, same formula, IL average would have been equals to I naught only. Okay, so IL average, inductor average current, it's a very important thing. You may be asked to calculate this, and you can see in 2021 we have a question from buck boost converter in which we have been directly asked to calculate the average inductor current. Okay, so if it is a buck boost converter or it is a boost converter, same formula we are having for average inductor current. If this would have been a buck converter, IL average could have been I naught only. Okay, so these formulas are important. You have to remember this. You have to practice these formulas. Now, so IL average is I naught upon 1 minus D. So we have to have I naught, and then we will be able to calculate this problem. And what has been given to us? We have been given that frequency is 25 kilohertz and duty cycle is 0.75. Okay. Now, so we only have these two data. So what we can do here? We don't know the value of I naught directly. So you know that I naught will be V naught by R. Okay. Or what is the value of V naught? So in case of buck boost converter, this output voltage. So this output voltage has a formula that V naught is equals to D upon 1 minus D times Vs. Okay. This is D upon 1 minus D times Vs. So if we just put this formula here, that output voltage will be equals to D upon 1 minus D times Vs over 1 minus D times R. Okay. So finally this formula reduces to a value of D Vs over 1 minus D square into R. Is that correct? So we have just put the value of V naught here. Okay, and you know that V naught is D upon 1 minus D Vs. So we will get this value, D Vs upon 1 minus D square into R. Now whether we have the required data to solve this particular equation? Yes, we do have. What is the value of duty ratio? It is 0.75. So you will put 0.75 here. What is the value of Vs? Source voltage, it is 20 divided by 1 minus 0.75 square into the value of R is 10 ohm. Okay, so when you will solve it, how much you are going to get as the average inductor current? Just see here. We will get 2 here, okay, and it will be 0.25 into 0.25. So 0.25, when it will divide 0.75, it will give 3 to us. So 3 into 2 will be 6. 6 by 0.25. So we will get 24 ohm. So that will be the answer. Okay. So just see what gate authority wants us to know. They want us to know about the formula of average inductor current. They just want to check us whether we know about how to calculate the value of the average inductor current in different cases of DC to DC converter. If you know, you could have solved this problem easily. Now the same problem might be repeated in the year 2024. In place of buck boost converter, they will give you boost converter. The formula remains the same. In case of buck boost converter or boost converter, they may give you a buck converter. Then the formula will become IL average will be equals to I naught only. So this is the way this problem can be modified and can be the part of the upcoming GATE 2024 exam. So I hope that you can solve these kinds of questions very easily without any hesitation. Okay. So let me move towards the next question. Now see this question. This was from inverters, and what has been said in this question is a single phase full bridge inverter fed by a 325 volt DC. So the source voltage is the DC voltage that we have. This is the VDC voltage. So VDC voltage is equals to 325 volt. Produces a symmetric quasi square wave form across AB. So this is the terminal AB where it produces a quasi square wave kind of waveform. Okay, not a square wave, quasi square wave. Okay, as shown in figure as well. So the waveform is also given to us. So this is the kind of quasi square wave we have. You know that this waveform, the width of this particular waveform is how much? It is 2D. Okay, so that is known to us. To achieve a modulation index of 0.8, what modulation index we want to achieve with the inverter? You know that modulation index plays a very important role. If you want to vary the output voltage of inverter, modulation index is going to play a very key role. So what is the modulation index given to us? 0.8. Note this point. Modulation index. So modulation index is given 0.8. The angle theta expressed in degree should be. So we want to calculate the value of theta. What could be the value of theta is what we have to calculate here. Okay. So theta is what we have to calculate here, and what they are saying, modulation index is defined as the ratio of the peak of the fundamental component of VAB to the applied DC value. So this line they have written to give you a hint if you don't know about the formula relating the fundamental voltage of inverter with the modulation index and the input DC voltage. If you know the formula, this is off. This you don't have to take care of this particular line. Okay. So they even have given a hint in this problem how we have to solve this particular case. So let's see what we will be doing here. First of all, just go with the given data. So if modulation index is given, we have to apply the formula of fundamental voltage. Okay. So fundamental peak to peak voltage. Fundamental peak to peak voltage, what it will be? Fundamental peak to peak voltage, if we want to calculate for inverter, this will be, we will write it fundamental peak to peak voltage. This will be equals to MA, the modulation index, into the DC voltage. Okay, modulation index times the DC voltage. Because this is a full bridge inverter, so we have written VDC here. If this would have been a half bridge inverter, we could have written VDC by 2. These formulas are well known to us. Okay. If you really want to know this concept, okay, and how these values are coming, so I have taken one lecture in our most expected concept series. So you can go there and you can watch the lecture number 7. Okay. So the lecture number 7 is exactly on the voltage control of the inverter. Right after this lecture, I will paste the link of that particular lecture and you can refer these lectures. Okay. How this formula we are writing here. Fine. So if this is a full bridge inverter which we have in this our case, so it will be VDC. If this would have been a half bridge inverter, we could have written VDC by 2. That's the only change we will be having. What if this problem is replaced with 3-phase inverter, which you may get in 2024. So what could be the formula that we will be using? In order to know that, just go to the most expected concept series that we have taken on YouTube. It is available in our playlist, and watch the lecture number 7 and you will get a clear idea about what formulas we have to use in respective cases. Okay. So coming to this problem, fundamental voltage will be MAVDC. Now just look here. Have a look into this case. So MA is basically 0.8, and what is VDC? VDC is basically 325. Now you will multiply this and you will get 260 volt. So just see, we have obtained the fundamental output voltage. Okay, peak to peak fundamental output voltage is now known to us. Okay, we have calculated with the given data. Now what actually the fundamental output voltage is, in order to know this, you have to apply the Fourier series. So what kind of waveform we are having? We are having quasi square wave kind of output voltage. So you know how you will write the output series how you will write the output voltage Fourier series. So output voltage, its Fourier series will be summation n equals to 135 to infinite, it will be 4 into VDC divided by n pi sine of n pi by 2 sine of nd and sine of n omega t. Okay. So this is the Fourier series expression for output voltage in case we are having quasi square wave type of output voltage which we are getting here in this case. What is D? You know that the 2D is the width of this output voltage that we are getting in each half cycle. Is that clear to everyone? Yes. Now from this formula, if we will try and attempt to find the fundamental voltage, what could be the fundamental voltage? So the fundamental and the fundamental peak voltage will be, we have to put n value to be 1 here. Okay. So if you will put n value to be 1 here, you will get 4 VDC over pi sine pi by 2. Sine pi by 2 will be 1 and sine d. So that will be the value. And we have already calculated this fundamental voltage. So if you see, we have already calculated this peak value of fundamental voltage which we have found out to be 260 volt. Okay. So what we will do here, we will just equate this value. This value is 260 volt. 4 into what is VDC? So VDC is given to us. We have the value of VDC which is 325. So we will put this value 325 divided by pi which is 3.14 and sine d. So right now we are having only one unknown here which is the value of d, isn't it? So we have only one unknown which is the value of d. So when you will solve this equation for the value of d, you will get an answer that d value that we have is 38.90 degree. So you will get this value of d. Okay. But this is not our target. This is not we have to find. We have to find here the value of, we have to calculate here the value of theta. Okay. So can you guys tell me, if this is 2D, how much will be this? If this is 2D, then this will be d. Yes or no? If we have this width as 2D, this will be d. And if d is known and this total distance that we have from here to here is pi by 2, then how much will be theta? So theta here will be pi by 2 minus d. Yes or no? So from this figure, we can easily find out what will be the value of theta. Theta will be pi by 2 minus d. Okay. So we have the value of theta. Theta has to be pi by 2 minus d, or we can say 90 minus d, or we can write the value of d. What value of d we have obtained? We have obtained d to be 38.90. So if we find the value of 38.90, sorry, if we put the value of d which is 38.90, how much we will get? We will get an answer of 51.1 degrees. So that will be the value of theta which will be the answer. Now whether we have to answer in degrees? Yes, we have to answer in degrees, not in radians. Whenever we are calculating angle, always take care of this fact whether we have to calculate in degrees or we have to find the answer in radians. So here fortunately we have to find the answer in degrees. Okay. So we will not be converting this degree into radian. Okay. Otherwise some extra efforts will be needed. So have you seen how easily we have solved this problem? Isn't it? If you know these formulas, okay, if you have the knowledge of this formula, if this is a full bridge converter, it is VDC. If it is half bridge converter, it will be VDC by 2. Same question will be repeated. And instead of full bridge, it will be half bridge converter. Instead of quasi square waveform, you may get a square waveform. Okay, this is how they can modify the question, and this question can reappear in the 2024 exam. Okay, so just see, if you know this formula, and if you are a student of power electronics, definitely you are aware of this particular formula. Okay. And if you are not aware of this formula, what you have to do, you have to go into the most expected concept series of IMS Gate Academy, and in the playlist there is lecture number 7. Just go and watch that lecture and you will get a knowledge how we are getting this Fourier series. If you don't want to remember this, you can. Okay. There we have practice how we can write these Fourier series easily. So just go and watch that lecture. So if you know this formula, you will find the fundamental value from here as well. Earlier we have also find out, you will equate, you will get the value of d, and then theta is pi by 2 minus d. So this is how we can solve this question very easily, isn't it? I hope this solution is clear to you all. Okay, so this was also carrying 2 marks. So there were 6 numbers, there were 3 questions carrying 6 marks. Okay, there were other questions as well, but those were very simple questions, statement type question. So I have not picked those questions here. Okay, so total coverage that power electronics had in the exam 2021 was around 9 marks. Okay, so these 6 marks were very easy to score. Okay, all you need to do is to believe on yourself. Now coming to power system, just see this question and read with me. We have a single core power cable in this question, and it has a total conductor resistance of 0.7 ohm and 0.5 ohm. Okay, so they may be having 2 different cable, and each one of them is having different resistance of 0.7 ohm and 0.5 ohm, and their insulation resistance between core and sheath are 600 mega ohm and 900 mega ohm. So sheath resistance are different and conductor resistance are different. And now when 2 cables are joined in series, okay, when 2 cables we are joining them, of course we will join them in series, okay, one after another. So when these cables are joined in series, what will be the ratio of insulation resistance to the conductor resistance? Okay, what will be the ratio of insulation resistance to the conductor resistance? This is what we have to find. Now what mistake students have done? If you are joining 2 cables in series, you know that in series resistance normally gets added. So they have added the conductor resistance and they have added the insulation resistance as well, which you should avoid. Why? Let me tell you. If suppose we have a cable, okay, if suppose we have a cable like this. So this is the sheath, or this is the insulation, this is the conductor, okay, and this is the sheath that we have. Just see here. Okay, so this is the conductor that we have. Let me remind you what a cable is. This is the conductor that we have. Okay, and this is the insulation that we have. And then this is the sheath. Okay, this is the sheath that we have. So in conductor we have normally 2 types of resistance. One is the conductor's own resistance. Okay, cable we have 2 resistance. One is the conductor resistance. So this is the conductor resistance, and the other one is the insulation resistance. Okay, the other one is the insulation resistance. Now the way I have mentioned the insulation resistance here, you can have a guess. If you are joining 2 cables together in series, the conductor resistance, what will be the equivalent conductor resistance? The equivalent conductor resistance, R equivalent conductor, it will be R1 plus R2 simply. Okay, and what are the values given? 0.7 ohm and 0.5 ohm. So it will become 1.2 ohm. Okay, so it is very much evident here. When you are joining 2 cables, these 2 cables are normally joined as 2 series resistance are joined together. So you will be adding these 2 resistances to get the equivalent conductor resistance. Fine. Now the way I have mentioned here the insulation resistance Ri, if you are joining 2 conductors in series, these 2 insulation resistances of 2 conductors cables will appear in parallel to each other. Okay, this is the fact that gate authorities wanted you to know. When you are joining 2 conductors in series, their insulation resistance appear to be in parallel with each other. Okay, so what will be the R equivalent insulation? Okay, so this will be R1 parallel R2. Okay, this will be R1 parallel R2. Let me call this equation 1. So what will be R1 parallel R2? We have the values. It is 600 mega ohm parallel 900 mega ohm. So what you will get? 600 into 900 divided by 600 plus 900, that is 1500. So how much you will get? what will be the parallel combination, equivalent parallel combination resistance. Okay, so when you will solve it, what you will get? You will get 360 mega ohm. Okay, so from here you will get 360 mega ohm. Let me call this equation 2. So just see, when you are joining two cables, conductor resistance are normally added, like a series resistors are added. Insulation resistance, they appear to be in parallel with each other. This is a small fact you have to keep in your mind. Okay, now we have calculated the equivalent resistance. Now what we have to find? We have to find here, when two cables are joined in series, the ratio of insulation to the conductor resistance. Okay, so we have to find the ratio of insulation to conductor. So let me divide equation 2 by equation 1. Okay, so equivalent insulation resistance is 360 mega ohm, 10 to the power 6 ohm, and equivalent conductor resistance is 1.2 ohm. Okay, it is 1.2 ohm. So now when you will divide it, how much answer you will get? You will get 300 into 10 to the power 6 ohms. So what you will be writing here? You will be writing here 300, which will be the answer. Just see, this is a small exercise we need to do. So we have to keep in our mind that insulation resistance appears to be in parallel. Okay, not in series. If you have remembered this fact, you could have nailed this problem without any problem, isn't it? So this kind of questions you may get in future as well. Instead of ratio, they may ask you about the addition, multiplication, difference. Anything can be asked with the similar concepts. Okay, so I hope you people have understood this solution, how we have solved this question. So let me move to the next question that we have. So this is the next question that we have. Now every year there is a question from bus admittance matrix, isn't it? And how to form the bus admittance matrix? Normally the bus admittance matrix is formed by inspection method. You will look into the diagram and very easily you will be able to find out what will be the Y bus matrix by calculation of diagonal element and off diagonal element. But what they have given in this question is, they have given such a diagram, such a bus impedance network, that it was not easy to find the Y bus matrix. Just see here what they have given to us. So in this question, we have a 3-bus network as shown in figure. Consider generators at ideal voltage sources. If row 1, 2, 3 of the bus matrix corresponds to bus 1, 2, 3 respectively, then what will be the Y bus matrix? So just look into the network. We have this network. If suppose there would not be this branch, if suppose there is no such branch, this particular branch, then we do not have any problem. Just by looking into the system diagram, bus diagram, and by the inspection method, we will be able to calculate the diagonal element and the off diagonal element. But this element is creating a problem where it will be accounted for in bus 1, 2, 3 or in between all. So this is creating a problem. Okay. So whenever you are not able to form the Y bus matrix by looking into the diagram, you are not able to calculate, you are not able to judge the off diagonal and diagonal element, what you have to do? Apply KVL and KCL. This is the trick. Okay. So if you have any problem in Y bus questions, what you have to do? Apply KVL and KCL. So this is the trick that you have to use. Okay. Remember my words. Whenever you are not able to find, not able to calculate the Y bus matrix, just by inspection, apply KVL and KCL, and that is going to help you. Okay. Just see how it is going to help us. So we have this figure. Okay. And this branch is creating a problem for us, and it is common to every bus. Let me call this voltage to be the V voltage. Okay. And let me call the bus 1 voltage to be V1. Current here is I1. Similarly, bus 2 voltage to be V2. Current here is I2. Bus 3 voltage is V3. Current here is I3. So how much current will be going into this branch? It will be I1 plus I2 and plus I3. Isn't it? So now we are trying to eliminate this branch. How can we achieve our target? So different buses are there, we have assumed different voltages, and collectively they will be giving a total current of I1 plus I2 plus I3 to this particular element that we have. Okay. Now if we simply apply KVL between bus 1 and this node, what you will get? If you will apply KVL between bus 1 and this node, you will get that the voltage V1, it will be equals to V plus I1 into Z1, isn't it? You will get V plus I1 into Z1. Now, what is V voltage? In this figure, if you want to write the voltage V, what you can write about V? V is simply I1 plus I2 plus I3 times Z4. Is that clear? Tell me. The voltage V will be I1 plus I2 plus I3 into Z4. Let me write it here. The voltage V here will be I1 plus I2 plus I3 into Z4. And what is the value of Z4? It is J. So let me write the value here as well, and you will get J I1 plus I2 plus I3. Fine. So this is how we can find the voltage of this node, which is V. Okay. Now what will be the voltage of the buses? If we have to write the voltage of bus 1, which is V1, it will be V plus I1 into Z1. Okay. Now put the values here. Just see what we will get. What is V? V we have calculated is equals to J I1 plus I2 plus I3. Okay. And I1, what is the value of Z1? Z1 has a value of J. Okay. So when you will solve it, what you will get? You will get J. J can be taken common, and you will get 2I1 plus I2 plus I3. This is V1. Let me call this equation number 1. Is that clear to everyone? Did you get how we have find out the voltage V1? So just by applying KVL, V1 will be equals to V plus I1 into Z1. And V we have already calculated. Okay. So now if you will put the value, you will get this one. Similarly, what will be the voltage V2? So similarly, if we are going to calculate the voltage V2 here, V2 will be what? Similarly, V plus I2 into Z2. Again, you will put the value of V, which is J I1 plus I2 plus I3 plus I2 into Z2. Okay. And what is the value of Z2? We can put the value of Z2 as well. So I2, Z2 is J. So now what we will be getting? We will get V2 to be equals to, if we take J to be common, we will get I1 plus 2I2 plus I3. Okay. Let me call this to be equation number 2. So if we are writing for V1, we are getting 2I1. If we are writing for V2, we are getting 2I2. So you can judge what is going to happen at V3. Similarly, you can write V3 to be V plus I3 into Z3, and finally what you will get? J. You will get I1 plus I2 plus 2 I3. Let me call this to be equation number 3. Okay. Now if we write equation 1, 2, 3 in matrix form, so what I will be getting? V1, V2, V3. Okay. And if I take J to be common here, and on the right hand side I will be having currents, which are I1, I2 and I3. Now write this equation in matrix form. What we will be getting? It will be 2I1, sorry, not 2I1, I1 we have taken, so it will be simply 2, 1, 1. Okay. Here it will be 1 from this equation, 1, 2, 1. J we have already taken out. It will be 1, 1 and 2. So just see what we have written here. These are the bus voltages and these are the bus current. Then this represents what? This represents the Z bus matrix. Okay. So we were trying to find out the Y bus matrix, but indirectly we have found out the Z bus matrix. And what we have done? What trick I have told you? Apply KVL and KCL. So just see, we have applied KVL here because applying KVL was an easy one here. So we have applied KVL and we have obtained the value of Z bus. Okay. Now you know that if Z bus is known to us, what will be Y bus? So Y bus will be inverse of Z bus matrix. Okay. So if you will take the inverse of Z bus matrix, what you will be getting? Okay. So I think that everybody knows here how to find the inverse. Okay. So if we have to find the inverse, we will be getting answer as D. That means what will be the value of Z bus? Minus 3 by 4 will be in the denominator and 1 by 4 will be there at, minus 3 by 4 will be in the diagonal, and at the rest of the places we will be having 1 by 4. So this will be Y bus matrix. Okay. So just see, if suppose you are not able to find out the Y bus matrix just by doing the inspection, it is a better practice to apply KVL or KCL. This is really going to help you out and you will find your answer. Okay. And this is exactly what we have done here. So now this branch, if you see, this branch which was actually a problem for us is not at all a problem for us right now. We have determined our answer. Although it has consumed much time of a student, okay, but you should be ready for these kinds of questions. Surely there will be a question from bus admittance matrix. Okay. So now GATE exam has a legacy of 35 years. Almost all kind of questions they have asked. So if you are preparing for PYQs, okay, if you have prepared all the PYQs, you are almost prepared for all kind of questions. It will become very rare that you will see any new question in the exam. Okay. And when I said that, I really mean it. Okay. So preparation of PYQ is the most important thing that the student has to do. And that's why, because IMS GATE Academy really cares for the student, that's why we came up with this particular series. Okay. Now moving towards the next question that we have. So just see this question. Let me read this question for you. An alternator with internal voltage of 1 angle delta 1 per unit and synchronous reactance of 0.4 per unit. So this is the data of alternator, is connected by a transmission line of reactance 0.1 per unit to a synchronous motor having synchronous reactance of 0.35 per unit. So this is the transmission line reactance, and then we have load as motor. Motor is having reactance of 0.35 and internal voltage of 0.85 angle del 2. If the real power supplied by the alternator is 0.866, then what will be the value of del 1 minus del 2 in degrees? Whenever you have to find angle, always see what in which unit you have to answer. In degrees we have to answer. Okay. So let me draw a diagram for the current situation. So let me assume that we have two buses here. Okay. At one bus we have connected the alternator. So this is the alternator connected to one bus, and there is a transmission line which is connecting this alternator to a motor. Okay. So this is the motor that we have, and it is a load for us. Now what data is given? The alternator has an internal voltage of 1 angle del 1. Okay. And it is having a reactance of 0.4. So it is having a reactance of J0.4. Okay. Let me call this voltage to be Vs. Let me call this voltage to be Vr. Okay. And then what is given to us? Transmission line is having a reactance of J0.1 per unit. Synchronous motor is having a reactance of 0.35 per unit. So what is the reactance of synchronous motor? It is 0.35 per unit, and it is operating at a voltage of 0.85 angle del 2. Okay. Now what has been given is that how much is the reactive power transferred from alternator to the motor is actually given. How much active power this motor is demanding from this alternator is given to us. Then what is the problem? We have to find out the angle. If suppose this angle is, yes, it is already mentioned, we don't have to mention the angle. So you can see here, this angle is del 1, this angle is del 2. We have to find out what will be the difference of angle del 1 minus del 2 here. Okay. So for that, what we have to do? You know the power flow formula. So if we have to calculate the power flow, P12, what it will be? It will be Vs into Vr upon X equivalent into sine of del 1 minus del 2. Now put the values. It has been given 0.866, isn't it? This has been given to us 0.866. Now Vs and Vr. Vs we can take 1. Let me assume Vs to be 1 and let me assume Vr to be 0.85. So 1 into 0.85 divided by X equivalent. Total X will be what here? The reactance of the alternator 0.4, the reactance of the transmission line 0.1 and the reactance of the motor which is 0.35. Okay. Then sine of del 1 minus del 2. Okay. Now when you will solve this equation for del 1 minus del 2, it will be sine inverse of 0.866 into 0.85. This summation will give you 0.85 divided by 0.85. So you will get 60 degree. Okay. Sine inverse 0.866. Sine inverse root 3 by 2 is how much? 0.866. So this small exercise we need to do here. We know the formula of power flow. If you are a student of power system, you are well aware of this formula. Okay. Now what we used to study, normally del is given for us. Vs angle del, we are habituated of writing Vs angle del, and we are taking Vr angle 0. But what if the difference, two different angles are given? Vs is having an angle del 1, Vr is having an angle del 2. Then instead of sine del, it will be sine del 1 minus del 2. So this small thing you should know. If you are aware of this fact, you could have nailed this problem. Okay, so this is how we have to approach for these kinds of questions. Okay, now I think this is the third or fourth time the GATE authority have asked a question related to power flow in the last 10 to 12 years. So you can just judge the impact of this equation. You can just judge the importance of this equation. Okay, so this is how you could have solved this question as well. Okay, so this is the these all are the questions that we have. These are all are the questions in which students have struggled. Okay, these all are the questions in which students have struggled quite a lot. Okay, but you can see how easily we are managing all the questions. So it's not a problem for you. Let me move to the next question. So just see this question. What has been given here? A three-phase balance voltage is applied to the load shown below. So we have this load. Okay, we have this load in which this reactance is J10, this is J10, and there is nothing connected to this terminal. Okay, this is a kind of short created here. The phase sequence is RYB. So phase sequence is RYB. Then we have to find the ratio of IB is to IR. Okay, so phase sequence is RYB. So we can see here is IR, here is IB, here is Y. So if we have to assume the voltage here, what will be the voltage VR? So let me call this voltage VR to be 1 angle 0. Then RYB is the phase sequence. So what will be the voltage VY? It will be 1 angle minus 120. Then what will be the voltage VB? This voltage will be 1 angle minus 240 degree or plus 120 degree. Isn't it? So am I doing anything unique here? Am I telling you anything that you don't know? Exactly not. Everyone is aware of these things. If we have a three-phase system which is balanced, three voltages will be displaced with respect to each other by an angle 120 degree. Yes or no? Okay. Now just see. So this is a balanced system. Now this is having an impedance, this is having an impedance connected, and this appears to be a short here, isn't it? So if we have to calculate current IB and IR. So in order to calculate this current, if suppose we apply KVL in this branch, so what we will be getting if we apply KVL in this branch? So KVL in this branch, if you are applying, it will give you a current IR. So what will be current IR? It will be VR minus VB, and this current will see an impedance of minus J10. Okay. Now put the values of these voltages. What is the value of VR and what is the value of VY that we have? So VR is having a value of 1 angle 0. VB is having a value of 1 angle minus 240 divided by minus of J10. So when you will solve this equation, you will get 1.173 angle 60 degree. Okay, you have to convert it from rectangular to polar and then you can get this answer. So this calculation, all this calculation I have done and I have obtained this value. If you want to re-verify this, you can do. Okay, so this is what we are getting. So this is how we can find IR. Okay, now if suppose we apply KVL in this direction right now, so we will get the value of IY. So if we have to find IY, it will be simply Vy minus Vb divided by J10. This is the impedance that this current is seeing. So what is IY? It is 1 angle minus 120. What is Vb? 1 angle minus 240. Okay, divided by J10. So when you will solve it, again you will get 0.173, but this time the angle will be 180 degree. Okay, you can re-verify all the calculation by your own side, and if suppose you are getting any other answer, you can post on the comment box. Okay, you can post on the comment box if suppose you are getting any other answer. If you are watching this video live now, you can post it right now after doing the calculation. If you are watching it a recorded one, you can post your answers as well. Okay, and we will see. But this calculation I have done and it is absolutely correct. Okay, just do the calculation from your side and comment on the comment box what you are getting. Okay, now since the system is balanced, so if the system is balanced, we are having IR plus IY plus I by IB equals to 0. Okay, so IR and IY are known to us. What will be IB? IB will be equals to minus of IR plus of IY. Okay, now put the values. Minus, what is the value of IR and IY that we have obtained? They are 0.173 angle 60 and 0.173 angle 180. So when you will solve it, you will get 0.173 and angle will be minus 60 degree for this. Okay, 0.173 and the angle will be minus 60 degree for IB. So this is what you will obtain. Okay, now what we have to calculate the ratio of IB to IR. So what will be the ratio of IB to IR? So modulus of IB to modulus of IR means we have to take only the magnitudes. So if you see here, when it comes to IB or when it comes to IR, both have same magnitude. Angles are different. Okay, 0.173 divided by 0.173, and how much we will get? 1. So what is the answer? The answer for this question is 1. Okay, now every year if you want to pick any paper, you can pick, and there is a question from 3-phase balanced or unbalanced system. And where we used to study this topic? Under the fault analysis. First of all, the topic which we are covering is unbalanced balanced system, symmetrical unsymmetrical system. Okay, so every year in every gate question there is a question from this particular topic. If you only prepare those questions, you are almost prepared for the gate exam about this topic. And in the year 2024, surely again you are going to get a question related to this topic. Okay, so I hope you have understood this solution as well. So this is the end of this particular lecture. So we have discussed questions of power electronics and power system, and have you seen how easily we are able to solve all the questions? Whatever is the formula required, how we are striking towards that formula. Okay, so like the way you have to build your approach of solving numericals, and PYQs are going to play a very important role, a very vital role in your preparation. Okay, because gate exam has a legacy of 35 years. Now it's the time where almost many questions and their concepts are being repeated every year. So practicing PYQs becomes an essential choice. Okay, So this is the end of this lecture. I hope you have enjoyed this lecture, and if you are watching this as a recorded one, just post your comments on the comment box. Okay, if you have any doubt, if you really have liked the video, okay, if you have really liked the content, just post on the comment box, like and share this video as well, so that it can reach to every student and each one of you must be benefited with this. Okay, so the PDF of this lecture will be made available on the Telegram group, and you can also join the Telegram group. The link of the Telegram group is given in the description box. So join our Telegram group. You will get the PDF of the question and all the updates related to the GATE exam as well. So thank you for watching this lecture. We will meet in the next lecture tomorrow, where we are going to discuss the questions of year 2020. Okay, so I will be waiting for you all tomorrow at 6 p.m. we will discuss the questions of year 2020. So thank you so much everyone for watching this lecture. Thank you.